Alright guys, today we're going to start chapter 22, which deals with oxidation reduction reactions. Now, oxidation reduction chemical reactions are actually some of the reactions we've already looked at. Things like synthesis and decomposition and combustion all end up being oxidation reduction reactions. We just haven't looked at them in that manner. So we're going to define what those terms mean, and we're going to figure out how to determine what's being oxidized and what's being reduced in a chemical reaction. So to begin with, we want to define oxidation and reduction. Oxidation is losing electrons, and reduction is gaining electrons. So in a chemical reaction, when something loses an electron, it is oxidized, and when something gains an electron or more, it is reduced. Now, in a reaction, both of them have to happen. You can't have one without the other. Something is gaining an electron because something else lost it. We can also call these redox reactions. It's just a shorter term than having to say oxidation reduction every time. Now, to help remember the definition, I want you to write down oil rig. And oil rig says oxidation is losing electrons, reduction is gaining electrons. Okay, so that's going to help you remember which is which. So let's look at an example and see if we can figure out oxidation and reduction. So here we have solid magnesium reacting with solid sulfur to produce magnesium ions and sulfide ions. Okay, so let's start with the magnesium. Here it started out as a complete atom, and then it turned into an ion with a +2 charge. So what happened was the magnesium lost 2 electrons. All right, so we would say that the magnesium was oxidized. Now the sulfur started as a whole atom and it turned into a -2 charge. That means the sulfur had to have gained 2 electrons to become the anion with a -2 charge. This means that sulfur was reduced. So these are called half reactions, and in the half reactions you're basically splitting up the oxidation and the reduction so you can see what gained electrons and what lost electrons, and how many electrons were gained and lost. The same number have to be gained and lost. You can't lose 3 and only gain 2, then you're going to have a random electron floating around out there. So you have to gain and lose the same number of electrons. Okay, let's look at one more and see if we can figure out what's oxidized and reduced. So we have a silver ion with a +1 charge reacting with solid copper to produce solid silver plus a copper ion. This is a single replacement reaction. So if we look at the silver, it started with a +1 charge and it ended up with no charge. So that means the silver gained electrons, and gaining electrons is reduction. So the silver was reduced. The copper started out solid and it became an ion with a +2 charge. That means the copper had to have lost 2 electrons, so it was oxidized. Okay, now not all redox reactions are that straightforward. Some of them are a little more complicated. So to figure out what's being oxidized and reduced, we're going to assign oxidation numbers. And this is basically just to keep track of the gain and loss of electrons. It doesn't mean anything other than that. So we do have rules that we need to use when we're assigning oxidation numbers. The first rule says that the oxidation number of an ion is equal to the charge of the ion. Rule number 2, hydrogen is almost always +1 in a compound. Oxygen is almost always -2 in a compound. The oxidation number of a free element is 0. Now that includes the diatomic Hofbrinkels. Okay, if it's oxygen gas, it's still a free element even though it's O2. Its oxidation number is still 0. For neutral compounds, the sum of the oxidation numbers is equal to 0. And for polyatomic ions, the sum of the oxidation numbers is equal to the charge of the ion. Okay, so we're going to use those rules to figure out the oxidation number for each element in the examples below. Okay, so for the first one, SO2, let's go back to our rules. Here's what we know. The oxygen is going to be -2, so directly above the oxygen, not as a charge, but directly above it, we're going to write -2. So each of the oxygens has an oxidation number of -2. There are there are 2 oxygens, so we have a total of -4, which means the sulfur has to be +4 to follow rule number 5, which says the sum of the oxidation numbers is 0. Okay, let's look at the next one. That's the chromate ion. Now this is a polyatomic ion, so our charge right here, -2, is what we want all of them to add up to. Again, oxygen is -2. -2 times 4 is -8. So for our total to be -2, chromium is +6. Okay, next we have the carbonate ion. Again, a polyatomic ion, the total is -2. So oxygen gives us a total of -6. That means carbon is +4. Let's go down here. Oxygen gas, it's a free element, so its oxidation number is 0. Now, let's look at these compounds. So in this compound, we have sulfate, and sulfate has a charge of -2, which means the total oxidation number for sulfate has to add up to -2. So O times 4 is -8. That means the sulfur has to be +6, okay? Now, to cancel the -2 of the sulfate, the 2 potassiums have to add up to +2, so each potassium is +1. Okay, same idea over here. Dichromate has a charge of -2, so oxygen is going to give us -14. 2 chromiums would have to be +12, so each one is +6, and then each sodium is +1. Okay, now, why do we care what the oxidation numbers look like? Well, when we get to a redox reaction, like these, we can tell what's oxidized and reduced by what things change their oxidation number. Okay, if the oxidation numbers go up or down from reactants to products, we know that things have gained or lost electrons. So we're going to go through each of these examples and assign oxidation numbers to determine what's oxidized and what's reduced. So for the first one, zinc is an element, so it's 0. The oxygen is -2, so manganese is +4. Don't worry about the coefficients. They don't have anything to do with oxidation numbers. Here, NH4, that's a polyatomic ion. It's ammonium, and the charge is +1. So if each hydrogen is +1, then the nitrogen has to be -3, and the chlorine has to be -1 to cancel the +1. Okay, in the product side, zinc chloride. Now we know this is an ionic compound, and if we took it apart, the charge of the ions would be +2 for zinc and -1 for chlorine. So in an ionic compound, you can use the charges. Okay, so for the next one, we have oxygen, which is -2, so that's -6, making each manganese +3. Here, hydrogen is +1, so the nitrogen has to be -3. And in water, oxygen is -2, and hydrogen is +1. Okay, so let's see what changed its oxidation number. If we look at zinc, it started at 0, and it changed to +2. So that's one thing that changed. What else changed? Well, let's see. The oxygens are all the same, nitrogens are the same, chlorines are the same, hydrogens are the same, so the only other thing that changed is the manganese. Okay, so let's figure out what was oxidized and what was reduced. So the zinc went from 0 to +2. To go from 0 to +2, it had to have lost 2 electrons, and losing electrons is oxidation. So the zinc was oxidized. The manganese went from +4 to +3. So to do that, it was reduced. It gained an electron. Now, if you think about reduction as in the oxidation number decreases, is reduced, that works too. So manganese was reduced. Okay, let's look at the next two. So just to begin with, we know that oxygen gas is 0, so we'll start there. Okay. Now, in the reactant side, the O is -2, NO3 is nitrate, and nitrate has a total charge of -1. So if we have -6, then the N has to be +5 to get a total of -1, and the K is +1 to cancel the -1. In the product side, O is still -2, but now we have nitrite, and nitrite has a charge of -1 as well. So -4 needs +3 to make it -1, and the potassium is still +1. All right, so what changed oxidation number? Well, the N changed oxidation number, and one of the oxygens changed oxidation number. So when we determine what was oxidized and what was reduced, let's look at nitrogen first. It went from +5 to +3. That means it had to have gained 2 electrons, and gaining electrons is reduction. So nitrogen was reduced. Oxygen went from -2 to 0, so it lost electrons, meaning it was oxidized. Okay, one more example. The chlorine and the bromine are both elements, so they're both 0. We know the hydrogens are both +1, so these have to be -1. So the chlorine went from 0 to -1. That means it gained, so it's reduced. Bromine went from -1 to 0, so it lost electrons, it was oxidized. Okay, we will do a lot more of these in class to practice with oxidation numbers.